Hi, guys. Welcome to a brand new episode of the Clear to Send podcast. I'm here today with Roel and Troy. Hi, guys. How are you doing?
Hello.
Doing very well.
We have Troy on today. Troy Martin from Calgary is here to talk with us about IoT. So before we get into the subject, and I also have a special announcement for you guys. So before we get into that, I'm just going to ask Troy to present himself. Troy, just if you want to tell the audience who you are, what you do, who you work for, and also tell us how you got started in Wi-Fi.
Yeah, for sure. So my name is Troy Martin, based in Western Canada. I work for my own company, so I'm an independent consultant. My company's name is Trogen Consulting. I do a mix of consulting, mostly Wi-Fi, but also wireless consulting engagements across a bunch of different verticals. And I spend the other half of my time delivering Wi-Fi training. So I'm one of the ECSE instructors. I also deliver some CWNP training as well as some customized wireless specific training. And you can get a hold of me on LinkedIn or on Twitter at TroyMart.
Awesome.
Well, and I guess I got my start in Wi-Fi. Sorry, I was working for a carrier in Canada, and I found myself so it was a lot of wired-based technologies, MPLS, VPLS, that kind of thing. But I'd go home and I'd do packet captures at night between my laptop and my access point. And it was kind of the early days of Wi-Fi, and so security was a big problem. So we were doing packet captures and trying to decrypt the keys, and it was almost like the curtains were being peeled back behind Wi-Fi, and we're kind of getting raw access to the protocol. And I got hooked and decided to make the leap full time into Wi-Fi, moving into the industrial space, deploying Wi-Fi in mines, chemical plants, nuclear plants, that kind of thing.
Wow.
And you actually have a CWNE number with only 2 digits, which is impressive.
Very impressive.
It seems a long time ago, yeah.
It's a long time ago. Yeah, and you've been on the podcast before, right?
Yes, I have. Yes.
And you do have your own podcast, right?
Yeah. So Phil Morgan, myself, and Tor started a podcast focusing on IoT. So it's the Channel 42.
Okay.
You find us on Twitter at the Channel 42 guys.
Awesome. Very good.
Awesome.
Yeah. We'll make sure we'll put links in the show notes so you guys can check that out. I think that's a very interesting discussion, just talking about like IoT and how that impacts us and what we do.
Yeah, and talking about CWNP, they did came out with a track where they're trying to focus a little bit more on IoT. And the first certification in this track is the CWISA. And CWNP was actually kind enough to give us a voucher to give away to you guys so you can actually take the CWISA exam. So the value of the voucher is, I have the exact amount, which is $224.99. So that's the value of the voucher we're giving away today on the show. If you go to the show notes, at cleartosend.net/256, we'll have a form out there, so you can register, and then we'll do a draw. Roel has his special drawing. He will use his special drawing skills to pick up the winner, and then we'll give that out to you guys. If you want to study for the CWISA, so you actually pass the exam, they actually have a study guide you can purchase from the CWNP website. And you can also, learn a whole bunch of IoT stuff on your own as well, and study the technology. What we wanted to do today on this episode is kind of do an overview of IoT and what IoT means for us Wi-Fi engineers, what type of technologies we'll be seeing out there in the world, at home, in the enterprise space, and try to see how those technology works and how they could have potentially effects on the Wi-Fi communications. And that's why we asked Troy to come on and have this discussion with us today. So what I think what we can do today is kind of talk about the different technologies, the IoT technologies we see out there, and maybe focus more on the enterprise space. Try to talk about the different use cases, and how companies start to use IoT more and more, for which purposes, and how they integrate or not in with the Wi-Fi infrastructure of the enterprise. company to try to see how it will fit with what we do in the field. I guess what we can start with is try to name the different technologies, IoT technologies that we find out there, which one are very popular, and then and maybe briefly present each of them. Do you want to start talking about them?
Yeah, for sure. So one of the good or bad things about IoT is that there's no shortage of protocols out there, and it's almost everything kind of gets lumped under the IoT umbrella. So you have a mix of different protocols that have been around for quite a while, quite a long time, and then that have evolved based on changing needs of the industry. So there's the whole Bluetooth. And then the BLE, which later became a subset of the Bluetooth standard, which are quite different protocols, even though they're all fall under with the same standard, standardized by the Bluetooth special interest group, or the Bluetooth SIG, but they have different characteristics and very different behaviors. And then you have other protocols that are based more on the 802.15.4 standard, so the IEEE standard, and leverage that as kind of a base or foundation. And some of them just use that as a physical or a MAC layer base, and then add some proprietary enhancements on top of that. And then you move into more longer range type protocols. So you have a mix of your LoRa, your Sigfox, your 6LoWPAN type technologies that kind of cover much broader distance. So we're talking like tens of kilometers, tens of miles, that kind of thing. You also have things on the cellular side. So you have your narrowband IoT, or LTE-M, which seems to be kind of a big trend that's being pushed out there right now. And then you also have some options for administrators and network operators to deploy their own cellular-based technologies. So the private LTE or the CBRS type models are becoming very attractive for those IoT spaces. And then more on the industrial side of things, you have some very specific protocols that are designed to operate in those harsher environments, things like wireless HART and the ISA 100.11a protocol. And so that's just a small snapshot of some of the IoT protocols you can have. And then the always popular Wi-Fi can also be a part of that mix as well. But there's quite the mix out there.
Yeah, and seeing that many technologies and looking at what CWNP is trying to create, I think it become when I look at it, it seems daunting, right? It's there's a lot to deal with, and you go, whoa, I have to know all of these technologies in order to even say take the CWISA and pass it.
So I think for a company to choose the technology, like the best technology for the use case, they try to look at what type of distance they need, right? There's a nice diagram that we'll put in the show notes. I kind of display the different IoT technology based on the coverage of the technology. So like, for long distances, you would use like Sigfox, LoRa. For proximity use cases, you'll use something else, maybe Wi-Fi, Bluetooth. So I think you can start there. If you feel like it's overwhelming, you don't really know which technology to use for a specific use case, you can start there and then start to see what's available to me, and then you'll have another list to go through, but a shorter list, I guess.
Yeah, so it always goes back to requirements, right? So trying to figure out what that organization's trying to do. How do you deal with that, Troy, when somebody is requesting your expertise? Like, what does that look like for these companies?
Yeah, so there's the interesting thing that I find a lot of Wi-Fi people will find about the IoT space is you sometimes you have a lot of you have less direction on which standard or which technology that you're choosing. All right, so you're trying to address the business need of the enterprise or the industrial environment, and so they may be asking you to bring in some sensors or some actuators to be able to control some type of device, but they're more interested in a specific unit. Or they have a specific vendor relationship already in place, right? And that vendor relationship, that will directly impact which IoT technology you can use, right? So an example of this in the IoT space or in the industrial space, if you look at control systems, right? So distributed control systems, there's pretty much two major vendors that exist out there. So Honeywell is one of them, and Emerson is the other. right? So depending on which vendor solution that you're implementing at your industrial site, that'll dictate pretty much whether you're going down the wireless HART path or the ISA 100.11 path, right? So at the Emerson camp being more wireless HART, Honeywell being more ISA 100.11a, but just the nature of your plant, if you have an Emerson like a Delta V DCS system deployed, that'll drive you down the wireless HART solution. Now, there's a lot of different vendors that produce different sensors. So you have options of different sensors and different vendors that you can source your products from, but they're all leveraging that wireless HART protocol. So it's not really a decision for you to decide which IoT protocol do I use. You could just choose the vendor that's making your sensors, and then find a way to design and deploy that wireless HART-based system into your environment. Other solutions where you have a few different options where you can evaluate different vendors, that potentially gives you some flexibility to decide, hey, am I going to use a Zigbee-based platform or a BLE-based platform, or maybe something that uses Wi-Fi? And now you have some more technology-based decisions to make as part of your IoT solution.
Mm-hmm. It almost feels like a proprietary solution, like the one you were describing was the wireless HART and the ISA 111A. You pretty much don't have any choice, right? It's different, I guess, different relationship with the technologies. Yeah. So if we talk about Bluetooth, because I think Bluetooth is the one we see more often, the most often when we work on on our Wi-Fi projects, mainly because now some Wi-Fi access points they start to actually include BLE radios in their APs. So I know like Aruba, Mist, they have BLE radios. I think Meraki as well. So do you want to talk a little bit about Bluetooth, BLE, the difference between Bluetooth and BLE, and how those different technology works more from the technical standpoint?
Yeah. So Bluetooth, it's been around for quite a while. First released way back in before the 2000s, right? So Bluetooth 1.0 was released with relatively low data rates, right? In fact, they call it the basic rate standard. So you hit super high data rates of 1 megabit per second, right? And they evolved all the way. They enhanced it, right? So they have their EDR, their enhanced data rate protocol. By the time they got to version 3, they'd improved the bandwidth all the way up to 24 megabits per second, right, for a data rate, which doesn't sound like a lot when we compare it to Wi-Fi. But the intention with Bluetooth was connect to a lot of smaller devices with much lower bandwidth requirements, right? To stream an audio, for example, or between your headsets and your mobile device of choice, a 24 megabit data rate path that's a huge pipe for audio transmissions. Right, so it kind of seemed like they were in a race to increase the speeds and feeds of Bluetooth. Right, but as Bluetooth kept evolving, they had other standards that they're trying to compete against, right? So the Zigbee was making some inroads, so they had to try counter that adoption across the marketplace. So they updated the protocol, and they put a lot of focus in preserving energy, right? So they wanted their Bluetooth transmitters or the beaconing devices where you could stick on a wall and do like the wayfinding type applications, or have them beaconing as you walked up and down the grocery stores. When you stood in front of your favorite box of dry cereal, you maybe could push coupons to you or interface with some sort of application on your phone. But there was a big emphasis on battery preservation. So they wanted those little beacon devices that are running on coin cell batteries to last, 3 years, 5 years, instead of having to replace it or charge it, every 24-hour window. And so they went in the opposite direction to preserve that battery life. The data rates dropped again. So in version 4.0, where they introduced the Bluetooth Low Energy standard, they made a modification of the protocol, and they also changed how it behaved on across the spectrum. So traditional Bluetooth, or Bluetooth Classic is sometimes referred to, it consisted of 79 different channels across your entire 2.4 band. And each of those channels had 1 megahertz spacing and 1 megahertz channel width, right? And with that, the Bluetooth kind of did a pseudo-random hopping pattern across the band, occupying the entire 2.4 band. And sometimes I refer to Bluetooth as kind of the cockroach of wireless. It's a very resistant and robust protocol. It can detect noise and avoid hopping to channels where it's unsuccessful. So it can can block list those channels and avoid moving to those spots in the spectrum, so it becomes quite resilient. With BLE, they dropped down from 79 channels to 39 channels, right? So now they're and they also increased the channel width, so they have 2 megahertz spacing. And it's interesting, they're very clear in the Bluetooth standard that the spacing is 2 megahertz. But what they also changed was the channel width. And it's a little more subtle to find that in the standard. There's some indirect references to the channel width, but it's also 2 megahertz wide or with spacing. And then Bluetooth is part of the beaconing standard. In order to make faster connections, BLE decided to advertise on 3 of those channels. Right, so now devices looking for those Bluetooth or BLE transmitters, they just have to scan 3 specific channels to detect the transmitter, and then they can establish a connection on one of those other channels. But they just scan those 3 advertising channels, which are, interestingly enough, spaced in between the Wi-Fi channels to minimize interference across Wi-Fi.
And you can clearly see that if you do a spectrum analysis, especially like in Ekaha, if you set your domain to Europe to scan a little larger, to go all the way up to channel 13, you can actually see those 3. And if you have, obviously, if you have BLE devices at home, but if you have like an iPhone, an iPad, or something like that, or an Apple Watch, you'll start to see that you have some sort of transmission between channel 1 and channel 6, around channel 4. So that would be, I think it's channel 38 for BLE. And then at the beginning of the 2.4 and at the end of the 2.4, you also have 2 transmissions, 2 megahertz wide transmissions that are the BLE advertisement. And like you said, Troy, one of the advantages of BLE is that you don't need to actually pair devices for them to communicate with one another. So it's not like, you have to pair your phone with your car so you can stream audio. There, with BLE, you could have devices that just exchange BLE frames with one another. Like an example would be two Mr. APs. They could exchange information using their BLE radios. And without you having to, establish the connection manually. So that's, I guess, another advantage of BLE.
Is BLE a common technology you see in IoT industrial sites, or is there one that's kind of the more go-to protocol that they're using?
So you'll see a mix depending more if you're more warehousing or more of a manufacturing space compared to a process or a batch type environment. So I find more of the latter scenario. That's where you tend to find more of the wireless HART ISA 100.11a, and a lot of that has to do with historical reasons, right? So generally, in those industrial spaces, as great as wireless sounds and as cool as it is, if you want it to work, wire it up. Right. And so a lot of the traditional deployments they're wired in all their sensors, right? But it takes a lot of time. It costs a lot of money to wire in those sensors. And for many, many years, for good security practices, there was an air gap between your OT system and your IT system. Right. And so the plant itself was an isolated deployment, an isolated network, which was disconnected from everything else, which brought a lot of advantages from a security perspective. But as we flash forward to today, there's a tremendous amount of business value inside the plant, right? And if you can gather the sensing information, so if you can monitor, thermal thresholds in your motors, your gears, your moving components, if you can monitor vibrations to see if it's increasing or decreasing or maintaining stability, instead of doing the traditional scheduled turnarounds where every 3 months or every 6 months you schedule a turnaround and you shut down your entire system, you do some maintenance, whether or not you need it, but you have those scheduled intervals. And obviously, while the plant's down, you're not generating your product, and you could be losing upwards of millions of dollars a day. So it's quite expensive to do these turnarounds. With the sensor information that's available, now the business intelligence side of things is, instead of doing these scheduled shutdowns, we can do predictive analytics. So we can predict when components will fail. So instead of doing a servicing every 3 months, we can say, hey, based on the vibrations or the thermal measurements that we're making, that this motor should keep running, right? It should last us another 8 months. right? So we can skip 2 turnarounds before we service that unit. This allows for faster and shorter turnarounds, which gets you back into production mode, making your product. And so deploying all these sensors around your environment, it's much more flexible with wireless. It's cheaper to install, it's faster to deploy, and you get that information back into your system to make those predictive changes.
So what would be the advantage of using something like wireless HART in a manufacturing environment and not like a sensor you would connect to the Wi-Fi network that's already available? You see what I mean? Like, what do we need another wireless technology?
Yes, so the wireless HART, because it builds on the wired HART technologies, so it uses the same frame formatting. It's built as recognized components within your distributed control platform, distributed control system anyway. So it has natural integration, right? If you were to deploy Bluetooth or Zigbee, those components, those sensing devices, don't have modules pre-existing in your DCS, right? So it'd be having a completely separate system and lacking all that integration to make feedback as part of your control loop. So if you were not deploying a DCS type system, then something like Bluetooth or Zigbee would be quite attractive. Now that there's some nuances within the protocols, just in terms of reliability, redundancy, that wireless HART has. So wireless HART has the ability to send its frames on different channels at different intervals to different nodes as it builds its mesh through the network. So it has basically a trifecta of redundant characteristics built within it. If you look at something like Zigbee, for example, so like your home lights or like your Philips Hue light bulbs in your house, you have 16 different channels that you can choose from as part of the 802.15 Zigbee protocol. But generally, your gateway picks one channel and locks onto that channel, almost like Wi-Fi. It kind of sits on a channel and it stays there, and all the devices transmit on that. And if you have a failure in one of your frame exchanges, you just have to wait for the next frame exchange. You're not moving to a different channel or different frequency to avoid any interference in your home or in your manufacturing plant. Where in the industrial space, we have that spectral diversity to account for any disruptions if they're intermittent or become permanent at the site.
Okay, so they build the protocol a little bit more. It's a little bit more robust and reliable, I guess.
Yeah.
For the environment. Yeah.
Yes.
And a lot of that is the clients themselves are tuned to that protocol, right? Whereas Wi-Fi, we have access points. A lot of the brains is built into the access points or the system, the controller, but we don't control the clients. And so, because it sounds to me that in an IoT environment, you're getting so much data, so much analytics, and all the other types of technology reporting, even AI already there in that platform. But with Wi-Fi systems, we're barely getting that in access points, but we don't have that with clients like our mobile phones or laptops. I don't know when a laptop is going to say, for example, like, oh, I don't know when that laptop's going to start having poor Wi-Fi performance because of its age or whatever driver it's using, right? We don't have that kind of data now for Wi-Fi.
Yeah, and it makes it challenging. Yeah, for sure. And one of the downsides of Wi-Fi is you have limited control over the latency between your frames and your communication requests to either retrieve information or to tell like a valve to open or close, right? And which could make the difference between losing your arm in a conveyor belt or losing lives, right? So that 100
Right.
milliseconds or the fractions of seconds that could be a big impact.
So the IoT protocols then are the reason why these companies use IoT protocols is because of the low latency and near real time type of communication that they can get, right?
That's a big driver to it and a big advantage that they have over Wi-Fi. They're tuned for very low bandwidth type applications where Wi-Fi really shines for high capacity, high data throughput. But a lot of these sensors are sending very small chunks of data. They're optimizing the frame sizes to communicate a lot while at the same time saying very little.
And in that case, are they doing any type of QoS? Is that even necessary in using these protocols?
Yeah, many of them do have built-in QoS capabilities, right? So you can flag different protocols. There's also different design constraints, right? So you can increase how often you get to updates, right? So generally in a wireless HART system, 4 seconds would be quite aggressive, 4-second updates. Whereas if you wait 10 minutes or get an hourly update, right? So if you're filling like a giant tank of oil, for example, they store thousands and thousands of gallons, and it takes hours to fill up these tanks, right? So if you're checking in every 10 minutes, hey, are we at the top level? No, okay, keep filling the tank. If we're top level, okay, shut off the valve, right? But every 10 minutes is a reasonable update. Now, wireless HART can go sub-second. You can do quarter-second updates, but it has a design impact as that mesh forms. The more frequent your updates, the fewer nodes you can have as part of your mesh, right? So generally, you're allowed to build a mesh of around 100 different nodes. But if you need more frequent updates, you have to shrink the size of that mesh so that you still have airtime available to receive those updates in sub-quarter of a second. So that's the trade-off. Which means you're deploying, more gateways, more hardware to deploy that type of solution. But generally, IoT is very, very low bandwidth.
And your description of the tank, I think that's a good one, because does that mean a lot of these protocols are used for automated things where there's less human interaction?
They're moving in that direction, which to be honest with you guys, I'm concerned about that. Because wireless will always be vulnerable to jamming type technologies. Right. So if you could have licensed or unlicensed spectrum and say, well, hey, if it's licensed spectrum, no one should be transmitting on there. If I'm a bad guy trying to do something bad to a plant, I don't really care that I'm jamming your signal if I'm already doing something bad. Right. So that can always happen. So unfortunately, eventually, I think we'll get there, but I'd be very reluctant to deploy a wireless type system as part of a safety control loop, where you need to, if a fault is detected, it automatically shuts down the process. And that's an automated function to enforce safety. But for a lot of the monitoring, I think wireless is fantastic there for the monitoring type stuff. And then you have open and closed loop type systems, right? So the open loop is you're getting feedback, but action isn't taken until an operator is involved, right? So it's open until someone's clicking a button on a keyboard, right? So you can see the sensor information increase, but you have human kind of part of that loop. The closed loop systems is where you're going more with the automation. And for some things, it can make sense. Others, maybe not. I was in a pulp and paper a processing plant, and they had a massive a rod that was spinning as part of their process, right? And it's tough when you have a motor or a reel like that that's in motion. It's tough to wire something like that in. Right. Obviously, that's going to make it difficult for cables, and so they put a wireless sensor on that, and the data that they got from that could keep that process in continuous motion. But there was a risk that if something jammed or interrupted that signal, it could cause issues. But the business advantage of having that sensing information there outweighed the risk. But that was kind of a closed loop system for that deployment.
Yeah. So security becomes a big factor here, and I'm assuming that these protocols build in the security to these protocols, right? You can't just have some other device that then connects wirelessly and pushes an action to some piece of equipment that you don't want, right? And what I'm thinking about here are those articles that we've read on Wired where somebody dropped a USB key somewhere, and then all of a sudden their system can be controlled, or piece of code gets pushed, and over time, like the sensors start changing their values where things are rotating faster than normal, right? So the wear and tear starts happening a lot faster. Do you get asked about some of those security implementations as part of your consulting with these IoT companies?
Yes, absolutely. That's a huge part of the concern and some of the reluctance that some organizations have in deploying that solution. And some of the protocols have very limited security options. Some of them, they describe themselves, "Hey, we have built-in security." And then so security is an interesting thing, right? If I have passwords, but everything's deployed with default passwords, is that really secure? Well, we have passwords, so we must be secure. But if you're deploying everything with the default password, any Yahoo in the parking lot can connect to those sensors as part of your process plant. If they have the password, they could start injecting frames. All right, so that has potential where you could give false readings, right? You could say the valve is closed when it's actually open, and then the process continues. Right, so there is potential for that, but wireless HART, ISA 100.11a, they do have a lot of capabilities built into the protocol. But to get the system turned up, they leverage a lot of default protocols, and so the vendor best practices are to modify the default protocols, the default network IDs, to make a more robust, secure deployment. But you always fight that with ease of use, right? To keep things easy and to add more sensors and to avoid having to update, the next field technician when they show up on site. With the new key, the new passphrases, a lot of default passwords are used, which I think introduces a lot of risk.
Yeah, I think it's an interesting industry to get into. It's very different from what many of our listeners may be used to, which could be open office space, right? Or even the more complex ones would be warehouses. But when you're talking about industrial sites, it's a different beast, right? You're not dealing with your standard drywall type scenario or high racking scenarios. A lot of machinery that moves and a lot of tracking that needs to be done, and not just tracking like movement, but tracking like very fine details of that equipment, so they can determine when they need to either do maintenance or find that something is working or there's an anomaly, right, that they need to detect. Is that what they're using these IoT protocols for?
Yeah, a lot of it is that. Also, as we move into, we're already there with our big data environment, getting all these different sensor points into the system and analyzing trends. And then predicting when you need to schedule new maintenance, how efficient that process is being used, or that piece of equipment, provides a lot of insight into the business side of the operation. So now connecting the IT network back into the corporate network, and putting a cable between those two networks, it adds to a security risk, but the value of that business information is tremendous. And I think to optimize processes going forward, a lot of organizations will start to need to use that.
And we have to think about, you mentioned it, try to connect the IoT network to the the LAN, I guess. When you deploy an IoT technology, you might have to deploy sensors and all of this equipment that will kind of overlay with the Wi-Fi if you already have Wi-Fi available. And then you have to think about that, and you have to think about how you're going to connect, that IoT network back to the LAN. With the BLE, we start seeing Wi-Fi vendors that put BLE radios in their access points, so you already have that close connection, I guess. I remember when we attended Mobility Field Day, well, a couple of years back, Cisco were talking about having like a Zigbee gateway within the AP running on a Docker container, something like that. So, in the future, maybe we can see more of that, more of IoT gateway integrations into the Wi-Fi equipment, so you don't have to overlay networks. Do you see that happening, Troy, in the future?
I'd like to see it happen. One of the challenges I find, though, is so you deploy all these separate IoT type systems, right? So you have your gateway for your lights, you have gateways for different plant pots, thermostats will come with their own gateway. And on that gateway, there's some sort of network manager, right, that's controlling that function. And in order for that radio in your access point to act as a gateway, we need that network manager software component installed on the AP. Otherwise, we have limited value to, or if we can, offload and redirect it. I think that's one of the pieces that's missing, is having that the network manager implementation, so that we can leverage those IoT related gateway technologies within the access point as we move forward.
Yeah, and it's funny you say that, because at home I have I started IoT at home with the Samsung Smart Things, which is like a Z-Wave gateway, I believe, that you purchase, and then you purchase Z-Wave compatible devices to interact with it. And then I got a Echo Dot to handle the all the Amazon stuff, Alexa stuff. I shouldn't say that word, but anyway. Guys, it's time to order
wearing headphones, so mine didn't trigger.
And then the other day I went to IKEA and I found those cool lights for kitchen countertops. Kitchen counters. You put them under the counters and you light up your kitchen. And I was like, cool, I'm going to buy them. And then you can also buy the gateway that goes with it, so you can actually change those lights with your phone, and you can interact with it with Alexa and all of that. But you need to buy a separate gateway, which is a Zigbee, I believe. Yeah. So now in my house, I have so I got it.
You
Why
have
not?
every
Right? So
single vendor in your house now.
yeah, and I think that's one of the challenges IoT as well. Like, you know, how do you, as different use cases will come to you, how do you choose? And then if you lock down or if you deploy a Zigbee network, do you really want to deploy another technology later on for another use case? I think it's sometimes it can be confusing and to try to
Yeah.
find, I guess, the technology that will work.
But
Yeah.
I think that's where CWNP is trying to solve some of that, right? Is
hmm
taking all these islands of systems and then being able to leverage things like the API and build a single solution that brings all of these together, right? And you can create a sequence of orchestration events where if you see something from one system, that could trigger an event on another system to counter that, things like that. And Troy, we both were at that CWNP JTA, and those are the things we were discussing. Was how can somebody tie all of these disparate systems together in order to build a solution for that organization? Because as companies try to come to market as fast as possible or try to create their product as fast as possible, you can't wait for one company to try to build a solution, right? There might be another company that already has it, so you got to put that in place, but somehow tie that to the rest of your systems.
Yeah, and I think that's going to be a growing market, and there's a lot of opportunity for wireless professionals to move into that space and start integrating all these separate wireless systems, and bringing the data from one into the other, and then cause changes in one system versus the other. And so Francois, your comment about the lights in your house, I thought it was interesting. So and maybe your experience differed, but it sounded to me like you found light bulbs that were cool, and you bought them because they were lights, and you wanted to light up spaces in your kitchen and your house, but you weren't really looking for a Zigbee solution. It was
No.
the lights that drew you, and they just happened to operate using Zigbee.
Yeah.
I mean, I didn't have to buy the gateway. You can also buy like a push button and then, use that to operate the light. But for an extra,
who wants
I
to push a
forgot,
button
like $40, they're like, you can also get the gateway and use Alexa. I'm like, sure.
Right.
So
Does it have an API at least so you can build your own,
I'm
Alexa
not sure.
app?
Well, I mean, since I don't know, since it's using Alexa, I'm guessing you can use the Alexa API and do some stuff with it.
Yeah, build your own app and then tell it to do something, which is great to have those echoes and the dots, because as everything is wirelessly connected, that seems to be the central point. That echo or dot can tie into other systems because it is using an API, and then being able to talk to your systems on your network, you can dictate what you want it to do, right? And you develop those sequences, right? Whatever that may be, like close a valve or open a valve. Like it'd be kind of scary to think about that as someone is sitting, like Homer Simpson, just sitting there and then telling it to go do something versus pushing a button to do it.
Yeah, and I think for us, sometimes it's hard to come up with use cases, like, because if you just buy IoT for IoT without really use cases behind it, you never end up using the smart feature, right? So me, for my kitchen, I almost never ask Alexa to turn on the kitchen light. I just press the button when I arrive in my kitchen. Like, the use case is not, it doesn't bring enough value.
You need
for
a
me
motion
to use
sensor
it.
now.
But so I think also for us, I think it will force us to talk more with the business to understand what they want to do. Because I think the use of the technology will come from the use case, right? And see if it brings value to them, to the business.
Yeah. Our use cases are simple. They're just first world problems, right? They're not. We're not solving business problems where we're trying to create a product. Like mine, if I say it right now, you can see my light turn off right here. I'll go, Alexa, turn off the garage lights, and then that would trigger it to do it, and it just does it for me. Like, because that's what I did coming down here. All my lights were off, but because I was upstairs getting my coffee before I came down here to record with you guys, I said, Alexa, turn on the garage lights. So when I came in, it wasn't completely dark. But that's just like simple use cases, but we need to scale them to like really complex business solutions. Like, what does that mean in terms of IoT? Why do we use certain bands, frequencies? The technology itself is more catered to the equipment they're using, right, Troy? So
Mhm.
so those are primarily the big driving factors there, because it's, if you've got a large installation that uses wireless HART, why bring in LoRa, for example, to do something like whatever you're trying to do? But I guess it's still evolving, right? This is the uh, IoT and industrial is evolving right now, because we are dealing with system
Mm.
or equipment that was largely not connected to the network.
Yes, so I think an interesting home scenario is if you have like your blinds, motorized blinds that can go up and down and let the sun in. And so the more sun that shines in your house, the sun's heating it up, or if it gets too hot, you close the blinds. You can have registers, so the vents that open and close let different levels of heat enter different rooms, and you pair that with different temperature sensors spread out throughout your home. And each one of those different components, the register vents, the blinds, and the temperature sensors, and thermostat on your wall, they could all be different IoT protocols. Right, so there could be the Z wave or the Z wave. There could be Zigbee, could be BLE. There could be Wi-Fi connected. Right, so you could have a multitude of different IoT protocols, but you need to bring those different vendor platforms together, different pieces of hardware, and so that, hey, when the temperature hits a certain threshold in this room, open or close the blinds, or
Yeah.
close the vents, right? And now, like you mentioned, well, the integration of those different platforms, that becomes really, really interesting, getting them to talk to each other, and hopefully they provide APIs where you can send those different commands to those different systems. But you're less deciding which IoT protocol to use. You're just, hey, this is the vendor that makes the blinds that I like, or has the best look and feel, or gives me the best aesthetics, and it just happens to use this IoT protocol. And now I need to work with it in my house. And then as part of the deployment, I need to deploy it in such a way that it minimizes interference with my existing Wi-Fi or with any other Zigbee type gateways that I need to have in my house.
Perfect segue. I wanted to talk about that. Like, we've been talking about different IoT technologies. Why don't we talk about the different frequency band used and which one could potentially interfere with Wi-Fi?
Yeah, so there's a lot of them that have potential to interfere with Wi-Fi. So you're looking at
Do they
things like
really?
Bluetooth, the 802.15.4 technologies. They all sit on Wi-Fi. So things like your Zigbee, your Z-Wave, wireless HART, ISA 100, they're also on the 2.4 bands. Whereas other technologies like LoRa and Sigfox, they're using lower frequencies, right? To get the longer range that we're talking about, they're using different frequencies, which have minimal, if any, impact on Wi-Fi.
Mm-hmm. Yeah, what I've seen with Bluetooth is if you have a lot of Bluetooth, you're going to have a lot of those hopping transmissions going around. It's not going to stop Wi-Fi completely, but it's going to increase the noise quite a bit. If you have a lot of Bluetooth devices, it's going to increase the noise a lot, and then your SNR will be reduced. And then you will feel it on 2.4 if you have a lot of Bluetooth. But if you just have a little bit of Bluetooth, you're not going to see it. You're not going to feel it on the Wi-Fi. I mean, if you have, if at home you have like a mouth that's Bluetooth and you use it every day next to your laptop that's connected to 2.4, you never felt that, the mouth of the laptop when not working properly. It's just too minimal. Yeah.
Yeah, I guess like in an office space scenario, if there's a large group of people, like cubicles or open seating area where everyone has a Bluetooth everything, your mouse, your keyboard, your headsets are wirelessly Bluetooth, and then because it's a nice office space, you've got the blinds that are controlled by Bluetooth or any other 2.4 frequency. So then what I see is people's devices think, as they're working, they think that it's a Wi-Fi issue, right? Because maybe your call isn't clear, right? It may be jittery, but it could be because you're using a wireless headset that is on Bluetooth, and at the same time, someone's microwaving something in the kitchen while, because it's 4 p.m. and the sun's shining, the blinds need to now close, right? And so all of this stuff is being triggered on 2.4, and I think, that's why we design for 5 gigahertz now, right? Because there's so much stuff on 2.4, which I'm fine with that if we leave those types of use cases on the 2.4 band. There's a good use case for it. And it's just a matter of understanding what is on that frequency, right? So if you do a spectrum analysis and you see all these frequency hopping going on, you might want to look at what kind of IoT or Bluetooth devices could be in the area.
Yeah, and you could also have a Zigbee. I've heard a company, they were building a new office space and they had Zigbee sensors for every doors. So you can, if you count the number of doors in your building, it's quite a bit.
Those door
you
badge,
notice that
the badge readers.
I can't remember for what use case.
I know we use those on campus. We have a separate deployment of access points that are Zigbee, and so they control the door badges or badge readers.
Yeah, so
not the badges.
If you ever done a design in Ekahau and you drew doors, you have quite a bit of doors in a building, so that could also add to the the list of devices that could transmit on 2.4. 2.4 is kind of like the IoT band.
Yeah, there was one office building I was working at. They had really small offices, almost cubicle-sized offices for everybody, but they wanted to soundproof everything, so they built floor-to-ceiling height glass walls for everybody. Wow. And so you had the glass doors that you could open, and it was giant fish aquariums you could see everywhere. But they were also conscious about the electricity they used. So they had motion sensors in every room that would turn off lights for every room. And as you walked up and down the hallways, you could hear click, 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 as the motion sensors were tripping. And the best part about the motion sensors that they picked is they pulsed on 2 different bands. They did a quick pulse on 2.4, and then they refined it on 900 megs. Right. And so there was all these 2.4 gigahertz pulses going as you walked up and down, bouncing off all the glass, creating tons of reflections and interference. And so their 2.4 environment was terrible, totally horrible. So we ended up having to move them to 5 gigs to avoid that by having a large density of these IoT devices, motion sensors, especially combined with the highly reflective surfaces. It was challenging for that spectrum space.
Do you guys see IoT moving into 5 gigahertz or potentially 6 gigahertz?
I don't think we'll see that happen. A lot of the SDKs for these IoT devices are 2.4 based. When they go to production, they can purchase the dual band or potentially tri-band radios, but that's not the focus of their product, right? So I have this Ava plant pot. It's made by a company in Vancouver. It lets you grow little plants from little sprouts and everything like that. But it's 2.4 only, right? So they don't really care about how it connects on Wi-Fi. They just want me to have the ability through my app to monitor my plants and see what the water levels are, and take pictures of them. But the other advantage of IoT or the 2.4 band is you get a lot further transmissions, right? And so technically, we say 2.4 doesn't go as far as 5 gigahertz, but we have larger antennas on the 2.4 band. So the net effect is we get longer range. And with that longer range, it allows us to save battery life by reducing our transit power. And for IoT, power and battery is king, right?
It's
you
critical,
need to preserve that. And I think those will be big drivers for the 2.4 band.
Yeah, because I've spoken to an engineer who designs mainly the software side of things, but those what do they call them? Those wireless vacuums that just roam around and vacuum your
Roombas
place, right?
And all those
something like that. And I was asking, we were talking tech about it, and so we were talking about Wi-Fi because they were Wi-Fi based, and he was adamant about staying on 2.4, and I was like, well, everything's on 2.4. Why don't you go to 5? And his primary reason was because 2.4 radios were just the cheapest. Like they were just cheaper to get. Yeah. And so that makes me think like that's why we won't see a lot of these devices on 5 gigahertz or even let alone 6 gigahertz, even though there was a lot of frequency to use there. Cost is such a huge thing because a lot of these devices, IoT devices, aren't very expensive to begin with, right? So they try to maximize their revenue.
And you have there's near global compatibility with the 2.4 band. It's supported pretty much everywhere you go, whereas it's pockets of 5 gigahertz, depending on what country you're in. Yeah. And to generate revenue on the IoT side of things, you really want to go after global size markets.
Yeah, so the regulatory side is going to be a big aspect to it, right? Because if you were to come up with a dual band vacuum cleaner, you now have to get that FCC certification on both on both bands, right? You have 6 gigahertz and you want to implement all 3, you now have to get that certification again for all 3. It's easier just 2.4, we're good. We'll just keep doing 2.4 vacuums because we don't have to recertify this adapter, this radio that we've gotten.
Mm-hmm.
Are you saying 2.4 isn't dead?
Nope. It's revived. For another purpose. Not for like our phones and laptops. It's now got another purpose, which is funny enough, it's critical now, right? You got Bluetooth low energy, all these other IoT protocols that operate over 2.4, yet we rely so much on them, right? Like your doors, like that's important. Like if you can't get into your building, that's a big problem. If you can't, because you can't update the badge reader.
Yeah, I've seen this funny video online yesterday where the guy has like a fully automated house. So he wakes up in the morning, his coffee is ready, and then everything opens on his way. He doesn't have to touch a thing. He goes out of his door in the morning, goes to the dentist, and the dentist, it works on his, teeth or whatnot. And then he has like a really big jar when he comes back home, and then he tries to get into his house, and his house is like, nope, I don't know you.
I don't know what you're saying, and your face doesn't. I can't detect your face. It's different.
But on the serious note, those IoT technologies on 2.4, they're very robust. One thing that I do when I teach EKH on the spectrum analysis section is, I show the student how reliable Bluetooth is. So I would just keep a Bluetooth connection, like a song going on a Bluetooth speaker, as I introduce a whole bunch of interferences on the 2.4, and somehow the Bluetooth always managed to work unless you completely jam the channel. So those technologies are very reliable, even though it's busy, even though you might have Bluetooth Zigbee and other technologies on 2.4, somehow they'll manage to find the 1 megahertz, 2 megahertz of spectrum they need to communicate on the spectrum. And actually, one day I had, go ahead.
That's one of the advantages of having the very narrow channels is you have a very low RSSI value. So BLE only needs about a -90 signal coming in for it to be able to detect signals. And also, how you when you channel bond, your signal noise ratio decreases, your noise floor goes up by 3 dB every time you double your channel width. Well, that's for from 20 to 40 megahertz. For our Bluetooth, we're using either 1 or 2 megahertz wide channels, right? So the noise floor for that becomes very, very low. So they can detect frames at very low signal thresholds.
Mm-hmm. Yeah, and one day I had a question from a customer. It's like a retail shop, and then he was telling me that they were having issue on their Bluetooth devices, and he was asking me, "Do you think our Wi-Fi interfere with Bluetooth?" And I was able to tell him no right away. Like, Wi-Fi will not interfere with Bluetooth. You might have the other way around where Bluetooth is impacting your Wi-Fi, but Wi-Fi will not impact Bluetooth. And then it turned out that they had like a bug on their Bluetooth device software, whatnot. Yeah. So but if you know that, you can actually help some people out. Yeah. Anyway, so I think we're reaching the top of the hour here. We could probably keep on going.
Yeah, I mean, you could spend a whole episode on some of these protocols by itself. But I mean, it's a good discussion with you, Troy, about just IoT in general and your experience with IoT and talking about different use cases.
Mm-hmm. And I guess if you want to listen more about IoT, you can check out Troy's podcast. When's the next episode coming out? No pressure, Troy.
We have a few that are in post-production, so we're just editing the video, and we hope to have those released out shortly, and then schedule more to come. But again, that's channel 42.
Channel 42. So Troy, before we close here, do you want to tell everyone where they can find you online?
Yeah, so you can get a hold of me on LinkedIn. Just search for Troy Martin, or on Twitter at TroyMart, or I also blog on a site WiFiVitea.com. Awesome.
And then if you want to win the voucher for CWISA exam from CWNP, you can head over to the show notes, cleartosend.net/256. We'll have a form that you can fill in if you want to participate in the drawing, and we will announce the winner in 2 weeks.
All right.
That's about it.
Thank you, Troy.
That's a really
for
cool
joining
prize.
us. Yeah, I think so.
Yeah, my pleasure. Thanks for having me on, guys. It's been great, Francois and Roel. Thanks again.
Thank you, Troy. And I've taken the exam. Troy, did you take the exam, CWISA?
Not yet. No, I was actually thinking about doing the connectivity and integration first, and then doing the ISA. But now, starting with the new year, the ISA is a requirement for new coming CWNEs.
Yeah.
Mm-hmm. Mm-hmm. Yeah. So if you want to become CWNE, you have to take it.
Yeah. So you guys better sign up for this voucher.
And I think if you need to renew your CWNE, you have to take it as well, from what I understood.
Maybe I'll keep the voucher for myself then.
Yeah. Actually, I think if you're a CWNE, you can request a free voucher for the exam. I believe that's what I've done because you've earned it, your CWNE.
Yeah.
So anyway, we'll close this episode right there. Thank you guys for listening. Check out the show notes for more details, and we'll see you guys next week for a new episode. Have a good week.
Bye, guys.
Bye-bye.